All right. So converting decimals to fractions. There are two types of decimals we're working with today. The first type is called terminating decimal. A terminating decimal is the first kind of decimal we're working with. The first kind we're going to convert. Right? In a terminating decimal, what happens, think about it. Don't say it yet. But what happens if you get terminated from your job? Or your cell phone plan is terminated? Or you run into the Terminator? What happens? What does it mean? Terminate means what? Yeah, to be cut off, to end, to be gone. A terminating decimal is a decimal that ends. A terminating decimal is a decimal that ends. It comes to a stop. A terminating decimal is a decimal that comes to an end, it stops. Let's talk examples. 0.089. That's a terminating decimal, right? It came to a stop, it ended. Negative 13.000004. It stops.
And it's and.
And it's and, not point. Thank you, Refugio. What about the number 6? Is that a terminating decimal? It doesn't have a decimal. You say yes, it does. Arlene, why? Yes, it does. Now, is it a terminating decimal? Yeah. I mean, whole numbers are technically decimals. You just don't go around and say the decimal part, right? I don't go around and say, well, actually, you owe me 3.0 cats in this exchange. You don't say that. I don't say, well, actually, I drove 1.0 cars today. You say 1. But is the number 1 technically a decimal? Yeah, you can make it into a decimal. And it's a terminating decimal because it ends. The second type of decimal we're going to work with today is a repeating decimal. And over the years, I've changed my definition of repeating decimal. I used to say it repeats the same pattern. But I've decided I don't like that. I'm going to say it repeats the same sequence forever. A repeating decimal repeats the same sequence forever. It's usually shown, if you write it all the way out, it's usually shown with a dot, dot, dot. Now here's why I say sequence. If my example is 0.5 0.3333333 dot dot dot. It's a sequence, right? It goes 3, then 3, then 3, then 3. I understand it's also a pattern, but we don't want to talk patterns because it confuses us. What about this one? 0.42942942943 dot dot dot. Didn't I just say it repeats the same sequence? And if I look at this problem, 0.42942942943 dot dot dot. That's not the same. But I'm telling you right now, it's a repeating decimal. I told you, I'm the teacher, right? I'm supposed to know what I'm talking about. I'm saying this right here is a repeating decimal, but it doesn't repeat. 42942942943 dot dot dot. Lily, what do you think happened? Yeah, the calculator's going to round it on us. Remember, sometimes you have to, if it's a repeating decimal, you just need to forget about that last digit. Here's why I say it repeats the same sequence. 0.12, 1, 2, 3, 1, 2, 3, 4, 1, 2, dot, dot, dot. Can you tell me what comes next? 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2. What comes next? Everybody tell me. 3, 4, 5. You know what comes next because there's a pattern. But is it a sequence? Is it the same sequence? Does the pattern repeat or does it change? It changes. So this is not, a pattern does not mean it's repeating. That guy does not belong in our repeating. You know, I really wish that there was an easier way to write repeating decimals. Because you know what? It's just such a pain. You waste so much pencil lead. I just really wish that there was a way out there that I could write a repeating decimal easier. Don't you?
Yes.
I mean, instead of writing 0.3333333333333 dot dot dot, I wish there was some shorter way to write it.
We're gonna come up with a way.
Sophia's smiling at me like I'm an idiot. Sophia, is there an easier way to write repeating decimals? What's it called? Do you remember? Anyone help Sophia out with the name of it? Bar notation. There is an easier way. My wish has come true. There's an easier way. Instead of writing 0.3333333333333 dot dot dot, I can use bar notation. And bar notation is super easy. All you have to do is write the sequence that repeats. You write the sequence that repeats. with a bar on top. You write the sequence that repeats with a bar on top. So instead of saying 0.33333333333 dot dot dot, I'm going to write 0. And what is the sequence that repeats, Refugio?
0.33 bar notation on top of the last 3.
Do I have to have 2 3s? No, I can just have 1 3, right? I can do 0.3 with a line on top of it. There we go. It's 3/10 repeating. How would you write 0.249 or 429 429 429 429 429 429 dot dot dot? Grant, how would you write it? 0.429, and the bar would go over all 3 of them, right? All right, smarty pants. What about this one? What about 9.183333333 dot dot dot? How would you write that one in bar notation, Julia?
0.183, the line doesn't.
She said 9.183, but the bar only goes over the 3. Julia, why only over the 3? Because only the 3 repeats. The sequence that repeats with a bar on top. The only thing that repeats is the 3. Easy enough? All right, so let's talk not just about decimals, right? The directions, or the title is Convert Decimals to Fractions. So there are 2 types of decimals. There's terminating, it stops, comes to an end. And there's repeating, that repeats the same sequence forever. Green doesn't show up very well, does it? Let's do...
Good job.
Okay, so we have, I'm going to make a table. I'm going to put terminating, and repeating. I'm going to liven it up with a little highlight action.
You should make a live stream. So like when people are asking, they can just get on.
I'm sure that's exactly what they want to do when they're sick, is live stream math class. Terminating and repeating. Terminating and repeating decimals. So we've got some rules to talk about. All right. Let's first, terminating decimals. Here's our example. A terminating decimal, it terminates, it ends, right? 0.6. Is that a decimal? Yes. Is it terminating? Does it stop? Yes. All right, it fits my criteria. We've already talked about these fractions, or these decimals. Carlos, do you remember how to change this into a fraction?
Yes.
What do you do?
You read it how it's supposed to be read.
Yeah. You put on your smarty pants and you read the fraction correctly. Ooh, that barely fit. Oh, yes. Good job. Read the decimal correctly. Read the decimal correctly. Do not say 0.6, because you know what? 0.6 doesn't help us. What you would say for this one is...
0 6 tenths.
Yeah. 6 tenths. And oh my goodness, it's a miracle. If you read it correctly, it automatically changes it from a decimal to a fraction. I read the decimal correctly. I'm done. Right? Check. Turn this in. All my homework's done. It's amazing. Mrs. Long grades it and she marks it all wrong. What? Did she lose her mind over the night and forget how to do math? Possible. Alexis, what'd I do? What did you do? What do you need to keep going? Yeah. Does it happen all the time? No. But you need to ask yourself, can it simplify? If it can simplify, you should simplify. Because, ladies and gentlemen, here's the deal. People don't talk in big things. They simplify things. They make it easier. Right? If I'm going to say you owe me 50 cents, I'm not going to say, well, you technically owe me 1/200ths of a dollar. You owe me half of a dollar. I simplify the fraction, right? How much of your homework did you get done? Well, I think I got like 88 20 seconds done. No. You simplify. And you don't answer a question like that. Unless you're weird.
It's me.
We look to see. The most common one is, are they both even? This is Molly. Uh-huh. I do.
Who's in trouble?
Right. Okay.
Who does something bad?
Okay. I can do it. Alright. Okay.
Who's in trouble?
Patrick's computer is ready. We'll talk about it after notes. Alright, so 6/10. Can it simplify? Ladies and gentlemen, they're both even. That's the easiest one to simplify, because if they're both even, Refugio, what can they be divided by?
By 2.
By 2. What's 6 divided by 2?
3.
And 10 divided by 2? We will learn about this later on in algebra, pre-algebra. 3 is prime, and 5 is prime. We're done. No more simplifying. Now, some of you may think, ugh, when my elementary school teacher made a big stinking deal about saying fractions correctly, I just ignored it because it was annoying. Well, you should have paid attention. So, in case you didn't pay attention, let's make a little chart. Oh, we have to write the number first. Let's write 0.748 9. I try. All right, I'm going to turn it sideways so you can see. This sevens column, right? This column right here. Right here. What place value is the 7 in, Carlos? Tenths. The 4, what place value is the 4? What place value is the 4 in, Grant? Hundredths. Haley, can you tell me about the 8? Thousandths. Refugio, tell me about the 9. 10 thousandths. I don't think you'll have anything in the 10 thousandths, but you never know. Right, so when you're converting, if it was 0.74, it would be 74 hundredths, right? And if it was 0.748, it would be 748 thousandths. And if it was 0.7489, it would be 7,489 ten thousandths. And there are your fractions. Right? Pretty easy. You already knew this, correct? All right. Let's go to repeating decimals. Here's our example. 0.45454545 dot dot dot. Is it repeating? Yes, because it repeats the same sequence forever. All right, so I'm going to skip 2 lines and go to my rules. The first rule is rewrite in bar notation. Make it easier on yourself. Most of the time, ladies and gentlemen, number 1 is already done for you. The only people who write repeating decimals like this are math teachers that are asking you, is this a repeating decimal? Or math teachers who are saying, hey, write this in bar notation. Everybody else just skips to the bar notation. So 0.45 repeats with a line over it. Step 2 is to read the decimal correctly. Huh, that sounds familiar. Step number 1 for terminated. It's the same thing. Except I just make sure it's in bar notation first. Then I read it correctly. What is 45, 0.45 repeating? How do you read that correctly? Sam? It's 45 hundredths repeating. But that can't be right. How do I know it's repeating? Here's the trick. If it's a repeating decimal, there is a third step that is not simplifying. There's a secret step. If it's a repeating decimal, the secret step, after you read it correctly, is you subtract 1 from the denominator. You subtract 1 from the denominator. That's only if it's a repeating decimal. That's the trick to repeating decimals. So instead of it being 45 hundredths, it becomes 45 99ths.
Why? Why do you subtract?
Because this value down here, 99ths, a denominator of 9 indicates that it's a repeating decimal. Every single time. And then, of course, we go back to our last step, which should always be, can it simplify? And I'm going to show you a trick. Do I want you to try to simplify most fractions in your head? Yes. Because there are still times in our world of math that we can't use a calculator. But ladies and gentlemen, on the school calculator, if you look right here, there's an N over D button. Do you see it? If you press that button, N over D, that stands for numerator over denominator. N over D. If you have this type of calculator, it's the A, B/C button. All right, so school calculator first. Type the N over D button to get your fraction, and then you type 45, and I want to get to the denominator, so this big circle are arrows. I'm going to press down to get to the denominator. I'm going to type 99. I'm going to press over to get out of it. That's not always necessary, but it's good to practice. And I press enter. 45 99ths simplifies to 5/11.
My calculator says 45.99 again.
I'll come help you. If you have one of these calculators with an ABC button, it's a little different. You type the numbers first. You type 45, press the ABC button. That's your fraction marker, 99, and then enter.